Now, magnetism. Now remember, whenever you hang a bar magnet, as I have said in the last class, whenever you hang a bar magnet, it will always align itself with the Earth's magnetic poles. है ना? अर्थ और जो ये poles है, हाँ, नॉर्थ और साउथ पोल से वो क्या करेगा? वो अलाइन करेगा अपने आप को. ठीक है? That is what a magnet usually does. That is known as a directive property. Okay. Now there are certain properties of magnets. Okay. Remember, unlike poles always attract each other and like poles always repel each other. Okay. Magnetism is both an attractive as well as a repulsive property. Okay. So write down. Unlike poles attract each other and like poles repel each other. This means that the North Pole and North Pole, when they come close to each other, they will repel. Okay, South Pole and South Pole will repel, whereas North Pole and South Pole will attract each other. Okay. Yes. Magnetism. Okay. नहीं समझा दूंगा, तुम अलग से समझा दूंगा. ठीक है? जब कोर्स एक बार सब खत्म होने तो उसके बाद फिर okay. Now if you see in case of a bar magnet, have you ever noticed a bar magnet? Have you seen the bar magnet? इसमें क्या होता है? एक नॉर्थ पोल होता है और एक तुम्हारा साउथ पोल होता है. ओके. Now there are certain fill lines. Okay, there are certain fill lines. These are invisible lines that are present both inside the magnet as well as the outside the magnet. Okay, and it is only present till a particular area. Say for example, if I keep a bar magnet here, the fill lines will be appearing, or the fill lines will be having their influence only till a particular range. Okay, that is known as the magnetic fill lines. Those are known as the magnetic field, and the lines are known as the magnetic field lines. Okay, that means beyond the magnetic field there will be no attractive or repulsive actions that will be shown by the magnet. Once a particular, say for example you have a nail, the nail has to come in the zone of the magnetic fields. If it is beyond the field lines or beyond the field, then the magnet will not be able to attract the iron. Okay. Now these are, remember, these are invisible in nature. Okay. Yes. Now if you see, just draw this diagram. Okay, from this simple diagram, I can tell you at least 3 properties of a magnet. Okay, these are known as your magnetic fields. Okay, usually the magnetic fields, they appear from the north pole of a bar magnet, and they enter the magnet through its south pole. Okay, Now that is outside the magnet, okay? But inside the magnet, what happens is that the magnetic field lines, they run parallel to each other, and they run from the south pole towards the north pole. Please remember this thing, okay? These entire space, this is known as your magnetic field, okay? That means if you have the iron beyond these lines, okay, there will be no attraction by the magnet. But if you keep the iron inside the lines, then it will feel a particular attraction by the magnet. Okay, am I clear? So write down the points, draw the diagram and write down the points. Yes,
इसका भी तो मैग्नेटिक
हाँ होता है, और कभी मैग्नेटिक फील्ड होता है, वो भी इस तरह का ही है, बट इट इज वो उसमें भी तुम्हारा आई हैव टू शो यू इन द पीपीटी, only then you'll be able to understand. There are certain bands because of certain what to say wings from the sun known as the solar winds. Okay, therefore उसमें कुछ थोड़ा ऐसा कुछ बैंड रहता है, लेकिन एक्चुअली अगर सोलर विंड्स नहीं होते तो वो इस तरह ही होते.
सर लेकिन बताया अगर कभी वो
Good. Yes. So याद की हो सके जो तो तुम्हारे magnetic field lines वाले magnetic field lines are originating from the north pole of the magnet. Okay, and they enter the magnet into the south pole. Therefore, you can see these directions, right? These arrows, they are originating from the north pole, and they are entering the magnet through the south pole. Okay, into the south pole actually. Now, that is outside the magnet. Okay. Now, inside the magnet, the magnetic field lines, they are parallel to each other. First of all, they are parallel to each other, and they run from the south pole towards the north pole. Okay. Next, till this line, if you keep any magnetic material only till this line, it will experience a pull by the magnet. Okay, but if you keep any magnetic material beyond these lines, that means beyond the field, there will be no attraction because it is away from the magnetic field. Okay, clear all bata do? Yes. Write down, in a magnet, in a bar magnet, in a bar magnet, in a bar magnet, the magnetic field lines originate from this north pole, and enter into the magnet, and enter the magnet through the south pole. Okay, within bracket likhiba, this is outside the magnet, full stop. Continue the sentence. The magnetic field lines run parallel inside a magnet, from the south pole towards the north pole.
सर मुझे पॉइंट नंबर 9
Point number 9. Point number 9 or Swama. In point number 9, you will find a bit, I will have come to that point actually. It talks about in which parts of the magnet you have the strongest magnetic pull. Okay, the strongest magnetic lines. Okay, usually in the magnet, what happens as you move away from the magnet, these magnetic fields, the density of the magnetic lines, the field lines, they decrease. Okay, they decrease in this direction away from the magnet. Okay, now whereas as you move towards the magnet, you will find that the field lines are very closely packed. Okay, the density of the field lines are higher near the magnet, and it is highest near the poles. Okay, highest at the pole. See, the fields are very concentrated, right? Here also, and inside the magnet also, the lines are very concentrated. That means inside the magnet and at the poles of the magnet, the magnetic attraction is the highest. As you move away from the magnet, what happens is the density of the lines they decrease, as well as the strength of the magnetic pull decreases. That is what number 9 means. Okay, point number 9. Okay, ठीक है?
Where the free lines tend to contract longitudinally, उसका मतलब है।
वही तो लॉन्गिट्यूडनली मतलब क्या, अगर तुम इसके तरफ जाते हो टुवर्ड्स द मैग्नेट तुम जाते हो, तुम्हारा वो जो होता है मैग्नेटिक फील्ड लाइंस होता है वो कॉन्ट्रैक्ट होते हैं. ओके, they will come nearer to each other. That means the density will increase. With increasing density, what will happen? The strength of the magnet will also increase. That is what. Okay, right now the next point. Point number 3. In a magnet, in a bar magnet, in a bar magnet, the magnetic field lines, the magnetic field lines, the magnetic field lines are more concentrated, at the poles, because of which the strength of the magnet, is highest at the pole,
So because of
which the strength is highest at the pole. हम सब लोग फुलकाले लिखिएगा हाँ, दिखदार है, अलग फास्ट करेगा हाँ. Because of which it is, magnet is highest at the poles. But in the middle of the magnet, at the middle of the magnet, the field lines contract. Which decreases the magnetic field, which decreases the magnetic pull, okay, ठीक है सर. Change the paragraph. Usually as we move away from the magnet, the density of the magnetic field lines, decrease.
the density
Of the magnetic field lines decrease. Density of the magnetic field line decrease, thereby decreasing the magnetic pull. Okay. There are certain things that are given in the book. I will not give you extra notes because it is useless. Okay. Now remember, if you are given a piece of a magnetic material, I mean a material using which, if you use that material, a magnet will pull that particular substance. Okay. Now such substances, they can be magnetized, either using a permanent magnet or using something known as an electromagnet. Okay, I'll be explaining what electromagnets after some time. But say for example, this is an iron piece, okay, a bar of iron, and this is a what? This is a magnet. Okay, it is there in a book. I will just show you the process. I will not give you the process in written. because whatever is there in the book, it is more than enough. It is a next page. ये मैं बोल चुका हूँ, ठीक है? वो जो लाइक और अनलाइक प्रॉपर्टीज. Okay. Say for example, this is your north pole. Okay, this is your north pole, and this is a simple iron bar. Okay, so what you do is that you take the north pole or the south pole. Say this is a north pole, and you rub it this way. You just keep on doing this way 30 to 40 times. After some time, you will see that even this piece of iron will start acting like a magnet. It will start attracting other iron nails or any other thing which is magnetic in nature. Okay, that means any magnetic substance can be magnetized either using a permanent magnet or a electromagnet. Okay, but you cannot do the reverse of it. Say for example, enuka tomanuka gosa, you cannot come this way. Okay, once you go this way, you will have to keep on rubbing the particular piece of magnetic material along the same direction. It cannot be in the reverse direction. If you go in the reverse direction, it will again get demagnetized. Understood? Clear? So write down the next point. Yes.
All methods भी है.
हाँ?
All methods भी है.
हाँ, मैंने बोला था ना using electromagnets.
नहीं, उसके अलावा.
नहीं. उसके अलावा ऐसा कुछ है नहीं. Either it is naturally operating magnets or the magnets are made using electricity. Okay, because electricity has magnetic effects. Remember. ठीक है? स्कूल स्टार्ट कोई लगा ये चैप्टर? मैं पढ़ा ना? Okay, write down. Any magnetic material like iron, comma, El Nico, just be very careful with this, it is written this way, El Nico, it is an alloy, okay, aluminum, nickel, cobalt, okay, right now, El Nico, comma, steel, etc., can be magnetized by a method known as the single touch method. In which the magnetic substance is rubbed using a permanent magnet in a single direction. Just wait a minute, I'm coming.
মোৰ পেৰেণ্টছে পঠালে মন আছিলে কিন্তু নপঠালে পাপাহঁত অফিচত আছে
Soldier.
Okay, this is known as a single touch method. Okay, next.
Sir, iron piece to hodaya karne magnetize ho jabo. Iron piece to hodaya karne magnetize ho jabo.
No, after some time it will lose. Gradually the strength of the magnet the magnetic property it will lose. Why it happens? Because if you do not keep the magnets properly, even if you do not store a bar magnet properly, what will happen is that it will lose its magnetic properties after some times. Therefore, whenever you go to buy bar magnets, you will always get to buy them in pairs. Okay, they are always in two pairs. Why? Because there is something known as a magnetic keeper. Magnetic keepers are two steel plates, either they're steel plates or iron plates, galvanized iron plates, where you. Huh? Wood other plat. Oh, wood other plat. Econometer. Look at the book here. Look at the book. Okay. Look at the book. Here there are two bar magnets. Okay. Here there are two bar magnets, and inside the bar magnet, I mean in between the bar magnets, we separate them using a wooden bar. Okay, and at the ends there are two plates. If you see, these are known as your magnetic keepers. Okay, a part thing. These are magnetic keeper material. Either it is usually steel, stainless steel, or it is also sometimes galvanized iron. Okay, because of which it retains the magnetic property. It will gradually die down, and whenever you go for keeping the magnets properly, you will always keep it using its unlike poles. Two like poles are never kept in close proximity to each other, because the magnets will start repelling each other then. Okay, therefore what we do is that we simply keep a wooden piece in between the two magnets, and if you see here, the north pole of one magnet is kept in contact with the south pole of another one magnet, right? And at the ends we keep the magnetic keeper. The same is the case with the horseshoe magnet. A horseshoe magnet is nothing but, have you seen a horseshoe? Hey, horseshoe to likhe hoy. It is shaped that way, and the magnetic field lines, they run in this manner. Okay, sir? If you bend it, what will happen? It will originate from this north pole and it will come in the enter the magnet in the south pole. Okay, sir? Hetu karone ki hoy ge ya magnetic field lines kini enuka run kore. Okay, from the north pole towards the south pole. Okay, you will not get such an elaborate design. Okay, am I clear? Even for keeping your horseshoe magnet, you also have a magnetic keeper. The same thing is used. Okay, we do not need the wooden plate or the wooden part. It's not required. If you want to buy a horseshoe magnet, you will always get in a single piece. Understood? Okay, yes, and it is much more easier. It is much easier. Why? Because using a horseshoe magnet, you do not need two magnets. Say for example, one of the biggest applications of magnet are in motors. Okay, in motors and generators. Without magnets, a motor is useless. Okay, therefore, usually we use horseshoe magnets in motors, DC, simple DC motors. Okay, because otherwise, to keep, that north pole lagibo or south pole lagibo. For that, we require two bar magnets. Now, if you have a single U-shaped magnet or a horseshoe magnet, a single magnet will serve the purpose. Okay. Remember, next thing, very important, magnetic unipole never exists. You will always get a magnetic dipole. You cannot have a magnet which is only north pole or which is only south pole. It is impossible. Okay. Therefore, magnetic unipole is impossible. Magnetic poles, they always occur in pairs. So write down the next point. Magnetic unipole is impossible. Magnetic unipole is impossible. Which means that magnets never produce a single pole. Okay. Next, there is another one way by which you can a particular magnet or any magnetic substance can lose its magnetism, okay, or its magnetic properties. Say for example, if you're hitting a piece of magnet very hard with a hammer, okay, that means application of pressure, okay, or application of force, repeated force, okay, repeated hammering, repeated beating of a particular magnet, it will make that particular substance to lose its magnetic property. Next is very strong heating. If you heat a magnet very strongly, it will again, what will happen? It will lose its magnetic property. So write down. Write down.
फिर हैमरिंग करने से क्यों
You will not understand. क्योंकि there are different types of magnets. और magnetism कैसे होता है कैसे नहीं होता है, it's a concept of class 12. ठीक है, क्लास 12 में तुम्हें you will find certain things in solid state, okay, kernel সার্কিট কি পাতা বস্তু থাকে, ঠিক আছে, এইখিনি তোমালোকে এতিয়াহে বুজি পাবা, अब नहीं समझ में आएगा, okay. Right on.
So same point.
No, next point. A magnet loses its a magnet loses its magnetic properties if point number 1, I mean subpoint number 1, if loses its magnetic properties if, okay, subpoint number 1, if it is hammered or beaten repeatedly, if it is hammered or beaten repeatedly, hammered or beaten repeatedly. Point number 2, if it is heated strongly, if it is heated strongly, if it is heated strongly, and point number 3, if it is not stored properly using magnetic keepers, if it is not stored properly using magnetic keepers. माइक में मैग्नेट क्यों यूज करते हैं, क्योंकि वो जो माइक का माइक यूजेस अ पर्टिकुलर प्रॉपर्टी नोन एज इलेक्ट्रोमैग्नेटिज्म, ठीक है, क्योंकि उसमें एक कॉइल भी होता है, ओके, वो कॉइल होता है, और वो कॉइल में जब तुम एक इलेक्ट्रिक सिग्नल मतलब तुम भेजोगी, व्हाट विल हैपन इज दैट इट विल वाइब्रेट द डायफ्राम, जो तुम्हारा माइक तुम्हारा स्पीकर जो होता है, उस स्पीकर में तुम्हारे एक ऐसा ब्लैक कलर का कुछ होता है ना, उसको हम डायफ्राम बोलते हैं, ठीक है, तो उस तुम्हारे कॉइल को, वो कॉइल क्या होता है, वो अटैच होता है इससे পৰীক্ষা এনেকুৱা দিবা ক্লাছত বহাই নেকি কোনোবাই নকৰিবা, অলপ আগফালে ইয়াৰ কৰিলে তুমি ক্লাছত এনেকুৱা নকৰিবা, ভাল নালাগে, ঠিক আছে। कॉइल क्या होता है, वो अटैच्ड होता है वो डायफ्राम से। Now if the diaphragm vibrates, only then sound will be produced. मैंने क्या बोला था, for production of sound what we need vibrations of a particular object, ठीक है, तो वो वाइब्रेशन तभी करेगा जब ये जो मैग्नेट है, जो कॉइल का जो मैग्नेटिक फील्ड है उसके साथ इंटरैक्ट करेगा, ओके, और उसको ऐसे वाइब्रेट करवाएगा, ठीक है, तब इसके तुम्हारा मैग्नेटिज्म होता है। हाउ दे आर यूज्ड इट्स नॉट रिक्वायर्ड, ठीक है, इट इज जस्ट यूज्ड फॉर वाइब्रेशन ऑफ द डायफ्राम, ओके। नेक्स्ट पॉइंट, very important thing, okay, there are certain magnets which are known as electromagnets. Magnets are actually of two types, one is permanent magnet and other is an electromagnet, okay. Remember, a permanent magnet is a magnet which is permanent, which has permanent magnetic field lines, okay, that's what magnetic field lines are, you cannot increase or decrease the magnetic effect of that particular substance or whatever it is, like say for example a bar magnet, a horseshoe magnet, a circular magnet, okay, ring magnet जिसको हम बोलते हैं, you cannot increase or decrease the magnetic strength, neither you can turn off the magnetic effect, but in real-time applications, we need magnets which can be magnetized when we require and can be demagnetized whenever we do not require them. Okay, these are known as electromagnets. Okay, not only they can be magnetized and demagnetized as per our will, but their magnetic strength can be increased or decreased by doing certain things. Okay, like increasing the number of coils, turns, I mean the amount of current that is flowing through it. Okay, কেতিয়া হবো কেলে হবো এটা বুঝি পাবা. Okay, that means you can increase or decrease the magnetic strength. Okay, those are known as your electromagnets. So right now the next point is your electromagnet. Electromagnets. Before that, please draw a diagram, only then you will be able to understand. And draw fast.
Sir, cell to the keyword.
Key, K-E-Y. Rheostat. Rheostat is actually something known as resistor in electricity. এটা তোমালোকে দৰকাৰ নাই কৰিব কাৰণে, it is just used to vary the amount of electrical current that is flowing in the circuit. Okay, itu এতিয়া কাৰণে ইমানে মনত ৰাখা, it's not required কি ধৰণৰ হয় কি হয় দৰকাৰ নাই. Okay, Most of the things are there in your book, therefore I will not be giving notes. It's not required actually. Okay, this Sunday, can you people take the class, the last class that we have missed? আহিব পাৰিবা নহয় এইটো Sunday? Sure আহিব পাৰিবা? 9টা বজাত আহিব পাৰিবা? দিনৰ 9 to 10? नहीं क्यों?
नहीं शायद पता नहीं
पता नहीं मतलब
मतलब कहीं पे जाना है
कहीं पे जाना है। কি হ'ল? একো নাই নহয় কিন্তু এইটো সানডে মই ক্লাস কৰিম okay this Sunday I will be taking an extra class okay or if possible I will be compensating the class on this Saturday itself. Let me see what I do.
Sir, Saturday night. School of practice কাৰণে
Saturday class to কৰিব কাৰণে আহিবা
evening
সেয়াইতো ইভিনিঙতে মাতিম মই দিনত মাতিম বুলি ভাবিছোঁ নেকি পাৰিবা নহয় yes সেইদিনাখন তেতিয়াহ'লে মই ডাবল ক্লাছ কৰাই দিম ओके तुम्हारा भी मिस नहीं होगा ठीक है सैटरडे को मैं करवा दूंगा एक क्लास ओके ठीक है सर क्लियर बोल Saturday then do one thing from 5:30 to 7:30 I'll be taking the class. I'll do 5:30 to 6:30 then 6:30 to 7:30. Okay? Clear? Yes. ठीक है आयुष
मुझे लगता है सैटरडे को भी
क्यों
पता नहीं मुझे जाना है कहीं
लेकिन मुझे क्लास तो लेना है ना बिकॉज आई हैव टू कंप्लीट द कोर्स ओके ठीक है सैटरडे ले लो नहीं एक्स्ट्रा क्लास तो এইটোৱে বেছি ভাল হ'ব সানডে লোৱাতকে কাম অন সैटरडे ओके प्लीज ट्राई आयुष ठीक है संडे हां कल मेरा क्लास 9 का क्लास है आई कैन नॉट कॉम्प्रोमाइज दैट क्लास बहुत बड़ा मतलब ऊपर वाला क्लास है नेक्स्ट now what is an electromagnet? An electromagnet, just listen to the definition first. An electromagnet is a temporary magnet which shows magnetic properties or magnetic effects only when electric current is passed through the coils of a cylindrical core, of an iron cylindrical core. Okay? This is known as a solenoid. Here you get to see there is a core, right? It is a cylindrical core. Majority of the cases, it is either a soft iron core or a hollow air core. And around this entire tube or this entire core, you have certain copper coils. Okay, coils of copper that are insulated. The wire is insulated. Okay. Now, only when you pass electric current through this, when you turn on the switch, only then it will show magnetic effects. Okay. Once you turn off the switch, that means switch is the key. Okay. Once you turn off the switch, what will happen? The magnetic field lines will die away, and the magnetism will disappear after some time. Okay. That means this is a type of magnet that can be magnetized. Keyhole. Magnetized or demagnetized as per your will. Okay. Now this thing rheostat. Okay. What is a rheostat? As I have told you, it is a particular device that is used to alter the amount of electric current that is flowing through a particular circuit. Okay. Now, if you increase the amount of current flowing through it, then the magnetic strength of the solenoid will also increase. If you decrease the amount of electricity passing through it, again it will decrease. Understood? Am I clear? Okay, write down electromagnet. An electromagnet is a temporary magnet. An electromagnet is a temporary magnet. Is a temporary magnet which operates only when which operates only when which operates only when which operates only when electric current which operates only when electric current is passed through the coils is passed through the coils is passed through the coils which are wrapped around a cylindrical core which are wrapped around a cylindrical core. Change the paragraph. Which is wrapped around a cylindrical core. Cylindrical core. Change the paragraph. A solenoid is an electromagnet which is made by wrapping insulated copper wire around a soft iron core, SOFT, around a soft iron core. ठीक है से? The next point. The strength of an electromagnet can be varied using the following factors. Okay, number one, the number of turns of the coil. Greater the number of turns, greater is the number of turns after semicolon. Greater is the number of turns. Higher is the magnetic strength of the solenoid, of an electromagnet rather. Magnetic strength of the electromagnet. Point number two. The magnitude of electric current flowing through the coil.
The magnitude of
Electric current flowing through the coil. Greater the magnitude of electric current, higher is the magnetic strength. Magnitude of electric current flowing through the coil. Higher is the magnetic strength. Point number three. The material of the core used. In order to, after full stop, or after a colon rather, give a colon. Of the core used. Give a colon. কি বুলি ক'ব of the core used, give a colon, okay, give a colon. For increasing the magnetic strength of an electromagnet, for increasing the magnetic strength of an electromagnet, materials like soft iron, a material like soft iron is used of an electromagnet, materials like soft iron is used. Just write a note beyond that, below that, write a note. Soft iron is a type of iron, which can be easily magnetized and demagnetized. Is a type of iron which can be easily magnetized and demagnetized. Easily magnetized and demagnetized. Well, clear one? It will point okay? Yes. Everyone clear with permanent magnets and temporary magnets? বুঝি পারা নহয় কলোচোন ৰিঅ'ষ্টেট মানে এনেকুৱা এটা ডিভাইচ হয় যোনটোৰে তুমি ইলেক্ট্ৰিক কাৰেণ্ট কিমান ফ্লো কৰি আছে এটা সাৰ্কিটৰ থ্ৰু তুমি ভেৰাই কৰিব পাৰা okay now only if you vary the amount of electric current flowing through the coil you will be able to increase or decrease the magnetic field okay or the strength of the magnet okay clear yes
Sir,
yes yeah.
रियोस्टेट
मतलब एक ऐसा डिवाइस जो हम यूज करते हैं एक सर्किट में like you can alter the amount of electric current that is flowing through ठीक है इसमें एक तुम्हारा स्विच जैसा कुछ होता है उसको हम जॉकी बोलते हैं ठीक है by sliding the jockey over the rheostat you will be able to control the amount of electric current that is flowing through the circuit ठीक है केनेকুৱা यूज কৰে এটো পিছতকে গম পাবা বাট এতিয়া দৰকাৰ নাই এটো it is simply just for now understand it is a device used for altering the amount of electric current flowing through a circuit ठीक है बुझी पाला yes write down next point
Sir, one metals to magnetic attract কৰা কেনেকুৱা নহয়
you will have to understand there are different types of magnet ferromagnetism ferrimagnetism এনেকুৱা ধৰণৰ বহুত ধৰণৰ magnetism থাকে paramagnetism diamagnetism ঠিক আছে Okay. Now, if you see for an electromagnet, it has the same effects like that of a permanent magnet. Okay, just as that it can be turned on and off whenever you require it, and it can also be, the strength of the magnet can also be altered as per your wishes. Okay, depending upon the applications. Now, there are various applications of electromagnets. Daily life, you use electromagnets in all sorts of electric gadgets. Majority in your music players. ठीक है जो तुम्हारा म्यूजिक का जो प्लेयर्स होते हैं ठीक है जैसे तुम्हारा स्पीकर्स हो गया कुछ हो गया उस पे भी हम इलेक्ट्रोमैग्नेट्स यूज करते हैं ओके नाउ इलेक्ट्रोमैग्नेट्स आर आल्सो यूज्ड इन थिंग्स लाइक मोटर्स डीसी मोटर्स ओके इट इज आल्सो यूज्ड इन generators either in AC generator or DC generator में भी हम use कर सकते हैं okay it is also used in generators also okay for generating electricity you will require magnets okay there are two types of motors actually permanent magnet motor बोलते हैं और एक को हम बोलते हैं इलेक्ट्रोमैग्नेट मोटर्स, ठीक है, जिसमें हम इलेक्ट्रोमैग्नेट का यूज करते हैं, ठीक है जानवी। नाउ अगेन, if you want to separate, say for example, if you want to separate certain magnetic substance from a scrap, from a pile of scrap, how will you do it? You cannot go and handpick it, right? So what we simply do is that we spread the scrap over a particular area and we just glide an electromagnet over it. Okay, now when you glide the electromagnet over it, all your magnetic things like your metals and other magnetic metals, they will be attracted towards the electromagnet. Okay, and you can dump it wherever you want. Okay, okay, clear है? Yes. Electromagnets are also used in certain metallurgical purposes. Metallurgy का मतलब क्या है? Metallurgy is a branch of chemistry that deals with the extraction of metals from their ores. Metals ऐसे available नहीं होते हैं. You will have to extract that from a particular mineral, a particular ore. Okay? तो उसमें भी हमें कभी-कभी electromagnets का ज़रूरत होता है. Okay? There is a process known as magnetic separation. उसमें तब यूज करते हैं. Understood? Clear हो से कहा तो? Yes. Now, if you see a compass, what is a compass?
Device that shows
Navigation.
Yes, it is used in navigation and shows the directions. Okay, so it has a needle which is a magnetic needle. Okay, now depending on that, we try to see whether a particular thing has attained magnetism or not. Because if you take a compass near a magnetic material or a bar magnet or whatever it is, you will see that the needle will start deflecting. Okay, it will start deflecting. So if you take an electromagnet and you keep it near a compass needle, the same deflection will be also shown here. Understood? Compass needle हमें usually what use करो in order to see what type of magnetic field lines are being produced. Okay, clear हो सकता है कि नहीं? Yes. Now, a single wire. Remember, whenever electricity flows through any device, it will create magnetic fields of its own. Okay. Now, even if that electricity is carried by a single wire, even then it will show magnetic effect. Okay. Remember, the type of magnetic fields that are produced by a single current carrying wire is circular in nature. It will produce circular magnetic fields. Okay? Now, there is a very famous experiment known as the Oersted's experiment. Okay? Using which it was shown that whenever current flows through a wire or any current carrying conductor, it produces a magnetic field. So write down the next point. Oersted's experiment. OERS TED apostrophe S.
So, non-metals expand करते हैं.
क्या?
Non-metals expand करते हैं.
Non-metals expand करते हैं, हाँ क्यों नहीं करते हैं? If you take oxygen gas, if you take fluorine gas, if you take any gas, all the gases they are non-metallic in nature. And जो naturally occurring gases हैं, okay, apart from the compounds, not talking about the compounds, ठीक है? वो expand करेंगे.
नहीं, गैस को छोड़ दो non-metals.
हाँ क्यों नहीं करेंगे? Although the expansion will not be very significant, but any material. I do not like shining teeth in my class. किसी भी मटेरियल को अगर तुम हीट करोगी तो उसमें एक्सपेंशन होगा ही होगा. Although the expansion is quite apparent in case of metals, okay, and certain alloys, ठीक है, लेकिन ऐसा हम नहीं बोल सकते कि नॉन मेटल्स एक्सपैंड नहीं करते हैं. All sorts of material they will undergo thermal expansion or thermal contraction. पढ़ाया था मैंने, right? Now, Oersted's experiment की हुआ this one. See, you take a single copper wire, okay? You take a single copper wire and connect it to a cell through something known as a variable resistance, or you take a rheostat, okay? The rheostat is again used for the same purpose for altering the amount of electric current flowing through that particular wire or the circuit, okay? And you connect it using a key and a cell, okay? Now, once you start passing current, electric current through it, and you bring a compass needle near it, you will see there is a lot of deflection which is being created. Okay. Now, if you see here, the deflection of the needle. The needle has a north pole and a south pole. Okay, it will be usually pointing towards the aligning itself to along the Earth's magnetic field. On and on. Now, if you take it near the wire that is carrying the current, you will see that the north pole is getting attracted towards the current. Okay, towards the wire. Okay, you put the wire above the compass needle, it will attract it. You put it below the compass needle, again the north pole will the north pole will shift towards the needle. Okay, this shows that there is a particular magnetic field which is being created by your wire. Okay, understood? So write down. Right now, Oersted's experiment shows that Oersted's experiment shows that Oersted's experiment shows that huh? Oersted's experiment shows that whenever electric current flows through a current carrying conductor or a wire, it produces an electromagnetic field.
Sir, carrying, sir.
Hmm?
Current carrying, sir.
Wire. Conductor का wire से लिखा है. It's the same thing. Current carrying wire or conductor. क्यों बोलो? It produces an electromagnetic field.
It produces
An electromagnetic field.
Sir,
Yes.
South Pole can attract নহয় এইটো
Experimental. Because South Pole attract নহয় কথা এনেকুৱা নহয় তোমাৰ ৱায়াৰটো ক'ত আছে ঠিক আছে ৱায়াৰ আৰু কাৰেণ্টৰ ডাইৰেকশ্যনটো কোফালে হৈ আছে now if you alter the direction of electric current what will happen is that the polarity of the magnetic fields in the wire will also change remember okay now what type of magnetic field is being produced by your wire depends upon first of all the magnitude of electric current and the direction of flow of current. If you reverse the flow of current, see in the next part what happens? Here the current is flowing from what? In the first part it is flowing from the south to north direction, right? Therefore your north pole is getting attracted towards it. Okay, understood? Now the next part is that you are now changing the direction of current. That means the current is now flowing from north to south. Okay, now if you make the current to flow from north to south direction and you bring a magnetic needle near it, you will observe that the south pole is now getting attracted towards the wire. Understood? Clear for a sec? Now this amount of attraction is dependent upon the amount of current flowing through it. Greater is the amount of current flowing through the wire, you will find that the amount of deflection shown by the needle is also increasing. That means attraction to bahi goise. ঠিক আছে যিমান attract কৰিব আৰু বেছি attract কৰি দিব ঠিক আছে বুজি পাইছা কথাটো সো এই পাৰ্টটো ভালকে চাবা মইতো ডায়াগ্ৰামত ড্ৰ নকৰো কাৰণ ইউজলেস হয় বুকত আছে ভালকে ঠিক আছে এই চ্যাপ্টাৰখনৰ বহুত বস্তু ভালকে দি আছে এটো কাৰণে মই জাস্ট বুজাই যাম কেনেকুৱাকে নোটছ নিদিও আন্ডাৰস্টুড ক্লিয়াৰ হৈছে কথাটো Clear one? A kohado bujalo, it is there in the book. Okay? Read through it and if you have a doubt, then come tomorrow again. ठीक है? आपको मैं बुझाई दूँ part 2. Okay? Next part. Next one, oscillator experiment. No, oscillator experiment. Next point I need to say. It is also observed that. It has also been observed that. It has also been observed that. It has also been observed that the. It has also been observed that the magnitude of deflection shown by the compass needle, the magnitude of deflection shown by the compass needle depends upon the magnitude of electric current, depends upon the magnitude of electric current flowing through the current carrying wire, magnitude of electric current flowing through the current carrying wire. ठीक है सर?
Magnitude of electric wire flowing through.
Wire. ठीक है सर? Everyone clear with this thing? Clear? Yes. Tomorrow again class at the same time. Day after tomorrow you will be having double classes. Okay? Well, sure.